Hello dear students, in our last class we discussed about one problem on exercise 12.2 in linear programming problem, and remember these problems are verbal problems. Okay, next, okay, these are all verbal problems. It means first we have to convert to entire situation problem to mathematical form. Okay, next problem please. Okay, this is our fourth problem on exercise 12.2. A manufacturer produces nuts and bolts. It takes 1 hour of work on machine A and 3 hours on machine B to produce a package of nuts here. Okay, and so it takes 3 hours on machine A and 1 hour on machine B to produce package of bolts. He earns a profit of rupees 17.5 rupees per package on nuts and rupees 7 per package on bolts. How many packages of each should be produced each day so as to maximize his profit if he operates his machines for at the most 12 hours per day or 12 hours a day? This is our problem situation. Just observe here what are the important things we need to remember here. First one, a manufacturer produces nuts and bolts. Okay, so they produces here two things. So first one is here nuts, second one is here bolts. It takes 1 hour of work on machine A. They given two machines here. So 1 hour on machine A and 3 hours on machine B to produce a package of nuts. To produce one package of nuts, here the requirement are 1 hour for machine A and 3 hours for machine B. Clear? Okay, next. It takes 3 hours on machine A and 1 hour on machine B to produce a package of what? Bolts. To produce a package of bolts. So he earns a profit of, what is the profit here? 17 rupees 50 paise or 17.5 rupees per package on nuts and rupees 7 per package on bolts. How many packages of each should be? Each should be means here nuts and bolts should be produced each day so as to maximize the profit if he operates his machines for at most 12 hours a day. At most, the word is very important here. At most 12 hours per day. It means here the total the machine operation machine as cannot exceeds 12 hours. It cannot exceeds 12 hours per day. Clear? 12 hours per day. So now first we have to convert the entire problem to mathematical form. So before going to mathematical form, first and foremost thing is we have to take the decision variables, and that variables are non-negative. That variables are non-negative. Just observe here. I will take here. Let x be the number of packets of nuts. Okay, I will take here. What is x here? X is the number of packets of nuts. Similarly, and y be the number of packets of bolts. So obviously x and y are non-negative. Once x and y are negative, you can go with your remaining things. First take the table, machine. So total we have machine A and machine B. Okay. So the products here, first product here, nuts. So what we taken here? Number of packets of nuts as here x and bolts. This is all take here y. So now take here availability. So availability of hours. Next. Okay. So and also last one take this as here profit. Profit. Okay. Next fill the all the data what they given here. First observe here. machines total we have the machine A and machine B. So in machine A, first observe here, it takes 1 hour's work on machine A. So machine A you 1 hour agutte, and 3 hours on machine B to produce a package of nuts. So one packet produce ಮಾಡೋದಕ್ಕೆ it takes here 1 hours on machine A and 3 hours on machine B. That become 3. For 1 hours it takes here, for 1 packet of nuts it takes 1 hour. For 2 that become 2 hours. For 3 hours. Suppose you have x number, that become here 1 into x. Clear? Similarly, for machine B, it takes, for the nuts it takes 3 hours. So for 1 package of nuts, for 2 packages 3 into 2, for 4 packages 3 into 4, that's why. Similarly for x number of packets, that become here 3 into x. Clear? Similar, come to the second one, for bolts. So bolts is not, it takes 3 hours on machine A and 1 hours on machine B to produce a package of bolts. To produce a 1 packet of bolt, it takes 3 hours on machine A and 1 hours on machine B. So take care, this will be 3 hours and this will be 1 hour. So for 1 packet it takes 3 hours. For 2 packets 3 into 2. For 4 packets 3 into 4. Similarly for y become 3y. Clear? Similar, this become 1 into y. Is it clear? Okay, next. So what is the availability here? In the last they given, so as to maximize the profit, if he operates his machine for at the most 12 hours a day. At the most means here it cannot exceed 12 hours in a day. That become less than or equal to 12. Is also less than or equal to 12. So both the machine operates at most 12 hours per a day. This has been clear. Okay, next come to the profit. What is the profit here? He earns a profit of rupees 17.5 rupees or 17 rupees 50 paise per package of nuts. That become 17.50. Okay. 17.50 rupees for 1 package of nuts. For 2, 17.5 into 2. Similarly for x, 17.5 into x. Clear? Similarly, for 1 bolt of 1 package of bolt, that become 7 for 1, and for y number that become 7y. This has been clear. This is the profit. So total profit obtained by the nuts is 17.5 rupees into x, and for from the bolt is here 7 rupees. Okay, this is the profit. So it is a total profit here. So total profit is sum of these two, that is 17.5x plus 7y. That become total profit obtained by the merchant from nuts and bolts. The sum of these two. Okay, then that become our objective here. Here objective is we need to maximize the profit, right? We need to maximize the profit. So maximize the profit means here we have to take the objective function for profit here. So total profit here agutte 17.5 rupees x plus 7y. That become the total profit. Here we need to maximize the profit. So what about our objective function? First write objective function. Objective function agutte, what is objective function here? The total profit 17.5 rupees into x or 17.5 into x or 17.50 into x plus 7y. So like this is here z. So z is the objective function. Z is equal to 17.50x plus 7y. So this become our objective function. Then what are the restrictions or what are the constraints? Constraints are, what are constraints here? First observe here, 1 into x something, but here x plus 3y. So x plus 3y become the total work hour for machine A. Total work hour of machine A. So it cannot exceed 12 hours. So that become x plus 3y must be less than or equal to 12. Is it clear? The total availability of work hours for machine A is here 12 hours. It means it cannot exceed 12 hours. So x plus 3y less than or equal to 12. Similarly for machine B, that become 3x plus y less than or equal to 12. So obviously rest of the non-negative constants are x greater than or equal to 0 and y greater than or equal to 0. This one part has been clear. So we convert entire problem to mathematical form. So next step is finding the feasible reason for these constraints. Okay, blank space please. First, take the given. What's the given here? We need to maximize z is equal to 17.50x plus 7y. This is our objective function. Constants and also given condition. What are the constants here? Constants are x plus 3y less than or equal to 12 and 3x plus y less than or equal to 12 and x greater than equal to 0, y greater than equal to 0. And remember, x greater than equal to 0 and y greater than equal to 0, they are non-negative constants. Okay. So now solve these two inequalities. So first write the equations involved in the above inequalities, right? Above inequalities are, so what are the inequalities here? First one, x plus 3y less than or equal to 12. I will take this as here x plus 3y x plus 3y is equal to 12 and the second equation 3x plus y is equal to 12. For the equation involving the above inequalities are x plus 3y is equal to 12 and 3x plus y is equal to 12. Now solve these two equations here. Just find the point of intersection of these two lines with x axis and y axis. To find the point on y axis, just substitute x is equal to 0. Put x is equal to 0. So this equation become here 0 plus 3 into y is equal to 12. What is here? 3y is equal to 12. So y become here 12 divided by 3, that become 4. But the corresponding point on y axis here 0, 4 and put y is equal to 0. In a substitute y is equal to 0, we left with here x plus 3 into 0 is equal to 12 because the value of y is here 0. So x plus 3 into 0 become here 0. X plus 0 is equal to 12. X is equal to 12. Corresponding point of intersection of this line with the x axis here 12, 0. The x axis here 12, 0. Okay. Next, we need to find the second equation. Second equation is observe 3x plus y is equal to 12. What is the equation here? 3x plus y is equal to 12. Similarly, substitute x is equal to 0 and y is equal to 0 for this equation. Put x is equal to 0. This become 3 into 0 plus y is equal to 12. So 3 into 0 again 0. 0 plus y is equal to 12. What is y is equal to here? 12. So y value become 12. So once the y value is 12, what is the corresponding point on y axis here? X is 0 and y is here 12. 0, 12. What do you obtain here? 0, 12. Next, and put y is equal to 0. In the above equation, we left it here 3x plus 0 is equal to 12. So 3x is equal to 12 because 0 plus 3x again 3x. So what is x then? X is equal to 12 divided by 3, that become 4. What is the corresponding point on x axis for the equation? 3x plus y is equal to 12 is 4, 0. Is it clear? The point here 4, 0. So here we obtain the point of intersection of these two lines with x axis and y axis. What is next method? Next method we need to find the solution region, whether towards origin or away from the origin. For that purpose, I will substitute x is equal to 0 and y is equal to 0. Okay. Now consider, first consider the inequality. What is the inequality for first one? x plus 3y is equal to 12 and second one is ನಮಗೆ 3x plus y less than or equal to 12. Okay, first inequality here x plus 3y less than or equal to 12 and the second one 3x plus y less than or equal to 12. Substitute x is equal to 0 and y is equal to 0 simultaneously. X comma y is equal to 0 comma 0. When you substitute x is equal to 0 and y is equal to 0, this inequality become 0 plus 3 into 0 less than or equal to 12. 0 plus 3 into 0 again 0. Total 0 plus 0 less than or equal to 12. 0 less than or equal to 12, right? This inequality is here true. Obviously 0 is less than 12. So once this inequality is true, the solution region is towards origin, right? Towards origin, right? Towards origin. Similarly for the second inequality, substitute x is equal to 0 and y is equal to 0. Put x comma y is equal to 0 comma 0. Substitute x is equal to 0 and y is equal to 0. Here we left with here 3 into 0 plus 0 less than equal to 12. 0 plus 0 less than equal to 12. 0 less than equal to 12, right? 0 less than or equal to 12. It means the inequality is true. The solution region is towards what? Towards origin, right? Towards origin. Okay, so nearly 50% of the problem has been clear. Next we need to draw the graph for these inequalities. So graph draw ಮಾಡೋಕ್ಕೆ ಮೊದಲು take the scale along x axis as well as the y axis as 1 centimeter is equal to 1 units. So take a pause and write down all the things what I written here. We need to draw the graph for these inequalities to find the feasible region. Okay, first nodi, what is the first equation here? X plus 3y is equal to 12 ide. What is the equation? X plus 3y is equal to 12 and the point of intersection of this line with the y axis here 0 comma 4 and with the x axis 12 comma 0. Okay, first take the point 0 comma 4. So this is the point 0 comma 4 lies on which axis? Y axis. Similarly for the second point 12 comma 0, this is the point lies on which axis here? X axis. Now join these two points. We point join ಮಾಡ್ತೀನಿ. So better to use the scale while joining the points. Okay. And write on the corresponding equation. What is the equation here? X plus 3y is equal to 12. Clear? X plus 3y is equal to 12. What is the next step? Next step we need to draw the solution region, whether it is towards origin or away from the origin. Clear? So towards origin draw ಮಾಡಬೇಕಾದ್ರೆ just take the points here. When you substitute x is equal to 0 and y is equal to 0, this inequality is true. Hence solution region is towards the origin. Towards the origin ಗೆ arrow mark draw ಮಾಡ್ತೀನಿ. Okay, this has been clear. What is second equation here? Second equation is observe ಮಾಡಿ. This is your equation 3x plus y is equal to 12. So 3x plus y is equal to 12. Corresponding point of intersection with the y axis here 0 comma 12. Similarly for x axis 4 comma 0. Okay, 0 comma 12 this is the point lies on y axis. Similarly for the second point 4 comma 0, this lies in x axis. Join these two points here. Okay, what is the corresponding equation of the line here? 3x plus y is equal to 12. 3x plus y is equal to 12. Okay, next what is the solution region is? Solution region is towards the origin, because when you substitute x is equal to 0 and y is equal to 0, for the corresponding inequality is true, hence the solution region is towards the origin. So towards the origin arrow mark draw ಮಾಡ್ತೀನಿ. This will represent the solution region for the inequality 3x plus y less than or equal to 12. Okay, next we need to draw for next inequalities. ಯಾವ್ಯಾವಿದೆ ನಮಗೆ? non-negative inequality, right? X greater than equal to 0 and y greater than equal to 0. This represent x greater than equal to 0 and y greater than equal to 0 above the horizon. Next we need to determine the common reason which is determined by all the constants including non-negative constants. So that reason is, you'll notice. So here we have the reason. So this reason is 3x plus 3y less than equal to 12 satisfies. Similarly 3x plus y less than equal to, that is also satisfies. Y greater than equal to 0, that is also satisfies. At the same time x greater than equal to 0, that is also satisfies. So here we have the common reason. This reason what we obtained here, this reason is obtained by all the constants including non-negative constants x greater than equal to 0 and y greater than equal to 0. Okay, so this reason, what we have the reason, this reason is called feasible reason, right? This is called feasible reason. What we call this is a feasible reason. So once you obtain the feasible reason, what is the next step here? We need to determine the corner points. Here we need to find out the corner points. So what are the corner points here? So here are the one point. I will take this is the point as A. Corresponding point A, coordinate here 4, 0. And this is point I label this as here point B. And here we have the point C. This will become here 0, 4. And another point here horizon, that is O. Opposite is 0, 0. Okay. So what is the feasible reason here? O, A, B, C. I repeat again. O, A, B, C is the feasible region. So once you open the feasible region, next step is find the corner point. First point is here A of 4, 0. So what about point B? So point B is nothing but the point of intersection of what? These two lines, right? 3x plus y is equal to 12 and x plus 3y is equal to 12. Now find the point B. To find the point B, we have to solve the equation 3x plus y is equal to 12 and x plus 3y is equal to 12. To find the point B, so one need to solve here equation 3x plus y is equal to 12, another one x plus 3y is equal to 12. How to solve this equation? We have the method by cancellation method. Cancellation method how to use martira? So if you want to cancel x, just equate the coefficient of x in both the equation. If you want to cancel y, equate the coefficient of y in both the equation. So now I will solve here. I will cancel x term. For that purpose, just observe the coefficient of x here. We have 3. For this equation, 1. So that purpose, I will multiply this equation by 3. Well, multiply by 3, that equation become here 3x plus 9y is equal to 12 3s are 36. Clear? Okay. What about this equation? Write on the equation here 3x plus y is equal to 12. On changing the sign, you get all are negative because all the sign having positive here. This becomes 0 because plus 3x minus 3x get cancelled. We left with here 0 plus 9y minus 5 become 8y is equal to 36 minus 12 is 24. What about y then? Y is equal to 24 divided by 8, we left it here 3. What is the y value here? 3. Substituting any one of the equation, we will get the value of x here. So I will take the equation, first equation 3x plus y is equal to 12. 3x plus 3 is equal to 12. 3x is equal to 12 minus 3, that become 9. 3x is equal to 9. What is x then? X is equal to 9 divided by 3, right? That become 3. What is the value of x here? 3 agutte. Similarly, value of y is here 3. So therefore the point become 3, 3. The point become 3, 3. What is the point B then? Point B is here 3, 3. I will write here point B 3, 3. So obviously we obtained all the points here. Point O 0, 0, point A 4, 0, point B 3, 3 and point C here 0, 4. So please written all the things what I written here. Okay. So what is next step? Next step we need to find the value of the objective function at corner point. We need to find the value of the objective function at corner point. Next slide. So now the corner points are O of 0, 0, A of 4, 0, B of 3, 3 and C of 0, 4. Okay, next slide. Next we need to find the value of the objective function at each corner point. Next. So here we written corner points O of 0, 0, A of 4, 0, B of 3, 3 and C of 4, 0, 4. So corresponding value of objective function here, when I substitute x is equal to 0 and y is equal to 0, what you obtained here? 0. And similarly, when I substitute x is equal to 4 and y is equal to 0, we obtained value 70. At the same time, when I substitute x is equal to 3 and y is equal to 3, we obtain the value 73.50. Similarly, when I substitute x is equal to 0 and y is equal to 4, we obtain 28. Okay, these are the values of objective function at the corner point. What is next step? Next step, we need to find the maximum value, right? So how to choose maximum value? Take the largest value among the value of objective function. What is the largest value here? 73.50. Can you get the conclusion here? 73.50 is the maximum value? No. So when you obtain this value, just observe the feasible reason. What is the feasible reason here? Feasible reason is bounded, right? The feasible reason bounded means here the largest value of the objective function become maximum value of the objective function. Clear? Reason is here bounded, hence 73.50 become the maximum value of the objective function. Okay. So from the theorem number 2 helutte. What is theorem number 2 here? It tells that when we have the feasible reason is bounded, objective function has both maximum value and minimum value, and the maximum value is nothing but the largest value of the objective function, and the minimum value is nothing but the least value or smallest value of the objective function. Clear? Okay. So here therefore the maximum value of z is 73.50. So where it attains? At the point 3, 3, right? Therefore the maximum value of z is 73.50 at the point 3, 3. So what will be the conclusion here? Hence 3 packets of nuts. What is here? X. What we taken here? The x is here nuts. That is here x become number of packets of nuts. Similarly for the value of y is represent the number of packets of bolts. Okay. Therefore hence 3 packets of nuts and 3 packets of bolts has to be produced each day, so has to maximize the profit. So has to maximize the profit. This is the maximum profit what you obtained here from this problem. So here 3 package of nuts and 3 package of bolts are very important. This is the problem. Problem is clear. And in our next class we discuss about the next problems on exercise 12.2. Thank you everyone.